play when we start talking about permutations, combinations, and we start talking about binomial probability. Because remember, binomial probability, the probability of n out of r, actually probability of r out of n, excuse me, probability of r out of n, probability of getting 3 right on a 10 question multiple choice test. So if I have 4 choice 10 question, I want to know what's the probability of getting exactly 3 of those 10 correct. Now, to get exactly 3 out of those 10 correct, I need to use the formula. That formula is going to be n factorial over n minus r factorial, because again, I don't care which 3 I get correct, so order does not matter. That's how all this ties together. Additionally, I say p, that's the number right, so how many did I want right? I wanted 3 right, so it'd be r, okay, out of wrong is q, so that's going to be n minus r. So in our case, we're going to say 10 factorial over 10 minus 3 factorial, 3 factorial, times, now 4 choices means our p-value equals 0.25. And I want 3 of them correct. Q means wrong, so that's 0.75. And if I'm going to get 3 correct, I have to get 7 wrong. So folks, one of the things we always have to look at is these two numbers have to add up to whatever that number is. These two numbers, these proportions have to add up to 1, and the two numbers have to add up to the total. So the whole formula has to match. Now, give me a second. I'm going to run a number on that. By the way, I have a pen from the Environmental Protection Agency in Illinois. So whether it's Illinois and Environmental Protection, the pen is so green, it has no ink in it, apparently being kind to the environment. Let me find one that works. Okay, here's what I have. I went ahead and worked this out, did a little of it by hand, say 7s are gone, then I have a 3, 2, 1, reduce, 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 reduce. I come up with 120 options. 0.25 to the 3rd power times 0.75 to the 7th power. Put it all together. You'll notice I put it in the calculator, but I put it in as 120 times 0.25 cubed times 0.75 to the 7th comes out 25%. So my probability is only 25%, and that's just for 3 correct. If I wanted 3 or less, I would have to add up the probability of 3. I'd have to do this again for 2. I'd have to do it again for 1. I'd have to do it again for 0. Add up all the probabilities, sum them together. So that's what you're talking about there for binomial. Do remember that in binomial, it's fixed number of trials. Each trial is independent. Only 2 choices, and fixed number of trials, independent, 2 choices, and probabilities for us remain equal throughout the whole process. So you have those things. Next thing I'm going to do is I'm going to go ahead and throw up a discrete probability chart. We'll find the mean, standard deviation of that. But before I do, let's take what we were just doing, binomial, and let's find the mean and the standard deviation for binomial. Remember, our p was 0.25. Our total n was 10, so all we have to do is the square root of n times p, which is the square root of 10 times 0.25. I'm sorry, there's no square. It's just n times p. Got in a hurry. Mu equals n times p, so it's 10 times 0.25, which is 2.5. That's how many I should be getting correct. Square root goes with the standard deviation, because standard deviation is always a square root, npq. So I have the square root of 10 times 0.25 times 0.75. If I grab it, put it all together. Actually, probably easier to see if I use this other one over here. So let's go on clear, second quit, clear, mode, just for giggles, function, quit. Okay, so we have second square root 10 times 0.25 times 0.75. Enter. And you're going to get 1.37. Okay? And again, if needed, you could set it up with a 2.5, go plus 1.37, be 3.87, minus 1.37, that's going to be 1.13, and then you could keep going twice more to give you an idea for the empirical rule. So that's the idea for binomial. I'll come back. We'll do a discrete probability in the next video.